Well, thank you so much, everyone, for being here. I think a lot of you have heard a lot about this book, and now it's finally here. We're going to celebrate as big and gay as we can. To begin with, I'm going to ask Seven to read a little bit from the book so you get a flavor of what you're in for, and then we're going to do a two-part discussion. There'll be more reading, more audience participation, a hot dog fight in the end, so you have to stay throughout the whole time. Please take it away, Seven.
Okay, let me take the first look at the introduction that I have taken since I did copy edits. Are we alone in the universe? On a cold November day in 1961, in a quiet mountain town in West Virginia, an astrophysicist named Frank Drake wrote an equation on a blackboard and took our greatest step towards answering this profoundly human question. Dr. Drake was on a mission unlike any other, to conduct Earth's first attempt to meet our galactic neighbors. On that day, at what would become the Green Bank Radio Observatory, 10 people were present. Today, there are thousands of people across the world working together to make the ultimate discovery. Much like a remarkable little planet, the third one from its sun, the equation on the chalkboard would eventually take on a life of its own. It would be hotly contested, written and rewritten, declared the prescient future of humanity, asserted useless, obsolete. Gene Roddenberry would include it in his pitch for a newfangled TV show called Star Trek. Physicists and philosophers alike would come to blows over what it meant, what it could mean. Today, it's our turn to learn about the Drake equation. It continues on the next page. How many civilizations are out there in the Milky Way that we could talk to right now? The Drake equation boldly contends that everything we need to conduct our galactic census can be neatly summarized in only 7 numbers. But these 7 numbers span a tremendous scale, from the birth of galaxies to the death of civilizations. R star, the rate at which new stars are born. FP, the fraction of stars that host planets. NE, the number of planets per star that could potentially host life. FL, the fraction of habitable planets on which life evolves. Fi, the fraction of life on a habitable planet that becomes intelligent. Fc, the fraction of intelligent life that would want to talk to us. L, the average lifespan of a technological communicating civilization. Multiply all those numbers together and you will get N, the number of alien civilizations in our galaxy that might want to chat. The order of the 7 variables is intentional. It progresses smoothly from things scientists are pretty sure about, to things we might be able to learn in the next few decades, to things we will almost certainly never discover. In a 2009 interview, Dr. Drake laid out an optimistic vision. He calculated N to be 240,000, which works out to be one communicating civilization for every 4,167 stars. But over a decade has passed since then. A lot of progress has been made towards the earlier of the 7 variables, such as the discovery of thousands of planets orbiting other stars. Somewhat less progress has been made in the nebulous middle variables concerned with the part of life between, quote, the primordial soup and, quote, the invention of the toaster oven. This book seeks not to answer the Drake equation, although we'll certainly take a crack at it, but to explain why it is so unknowable. Above all else, the equation is a vehicle in which we will take a remarkable journey through the science that's really 20 sciences in a trench coat, astrobiology. Beginning with the Big Bang, we'll explore the lives and deaths of stars and their planets. We'll ask what makes a planet suitable for life, not just water, and what life really needs to get going, not much. We will learn about the kinds of big catastrophic things life has survived, and the kinds of big catastrophic things that are still on our horizon. Finally, we'll tie it all together with a whirlwind tour of astrobiology's present and future, and if you're really feeling inspired, good news. We're going to talk about how you could be the person who gets to make first contact. So join me on this expedition through space and time as we knit together the threads of the scientific method into the rich tapestry of our living, breathing world. Together, we'll peer through the lens of science at the endless creative potential of the cosmos and draw ever nearer to answering the question asked by our distant ancestors and our present-day comrades alike, are we alone in the universe? The galaxy awaits. Let's go.
Okay, So much like a hot dog, the Drake equation has many ingredients, and this was a good tour.
That's incredible.
But before we sort of all become experts in the Drake equation by reading your book, can you maybe give us a little bit of your personal history? Like, what was the meet cute? When did you learn about the Drake equation, and why has it been something that motivated you to write a book?
That's a great question. So I don't remember the first time I immediately became aware of the Drake equation, but I can tell you that I first really thought hard about it when I was I had just graduated grad school, and I needed some kind of interesting way to put together all of the really different research projects I was working on. And a professor who was advising me at MIT was like, she took one look at it, and she was like, that's obviously the Drake equation. And I was like, oh, okay, well. And it turned out it was. I was studying stars, the first variable, and I was studying planets, the second variable, and I was studying planetary atmospheres, the third variable. So whenever I applied for grants and proposals and, fellowships and all that stuff, I would be like, I'm working on the Drake equation. I didn't get any of those proposals, but the point is that that's when I really became aware of it. And so when I shitposted my way into the hearts of editors at Princeton, and they were like, would you like to write a book? And I was like, yeah. I thought really hard about, what I would like to write a book about. And it just, the first thing I thought of was the Drake equation. And I started looking into it, and I realized that there hadn't really been a lot of books about the Drake equation since the discovery of planets going around other stars. So there was a lot of ground to cover. And it turned into Cloudy with a Chance of Starships.
Incredible origin story. Maybe we can try and situate it in the current moment. Why is it a good idea for folks who haven't spent years living and dreaming the Drake equation to learn about it right now? You just said so many things tie into it. What are the things that folks can gain from saying oh yes, I too should care about the Drake equation?
So the Drake equation, spoilers for the book, but it really has no answer. It's a remarkable educational tool. And so what people should know about the Drake equation and why they should care about the Drake equation is because it is literally like Carl Sagan's ship of the imagination, in which we could take a remarkable journey through all this incredible science that is literally, it very, very literally is all these sciences in a trench coat. It is physics, it is math and network science, it's biology and astronomy and chemistry, and it's just something that neatly ties together all of science into a nice little bow that we can just learn about all these things at once.
There are a few things people who know you know about you. You're smart, you're funny, you're a great educator, and you're queer. So let's hit that last part. What is the queer lens in the Drake equation, and should other queers try and find something of ourselves in this sort of smorgasbord of sciences?
So I think the two of us know very well that physics is just so gay. Let's talk about the photon, the thing that is both a particle and a wave. Probably the most immediate example of how physics is queer.
That is me.
What?
That is me. I am the photon.
Yeah.
Not a boy, not a girl, but a photon.
Amazing.
Yeah.
But so I really feel like science is just such an inherently queer thing that sometimes get put into a neat little box as things that happen by men in lab coats at prestigious institutions, and there's nothing queer or weird or messy about it. But science is kind of a hot mess. And so as people who are, reflective of, a chaotic and dynamic and changing nature, we should care about how science is also dynamic and messy and changing and chaotic. And also, hot take, I know that the gay community loves astrology, but I'm here to tell you that we have astrophysicists too. We got astrophysicists too. Let's look at the universe too.
you gotta go very, you have to be very like astro curious in all directions.
Yeah, you really gotta get real astro curious about it.
I think that like one of this compelling things about something like astrobiology is that it is so forward looking. Like you're always on the frontier, you're always trying to discover something new. Queer folks are also always on the frontier of meaning we sort of belong here. And it's a fast changing thing. We're always discovering something new. You started writing this book, I believe, 4 years ago. Can you give us a sense of like in the 4 years you were writing and editing, like what things changed? Did you have to go back every time a new exoplanet was discovered?
Kind of. I think one of my favorite things that changed about astrobiology in the last like 5 years is that we figured out what the wow signal is.
Tell us about the wow signal.
Okay, so the wow signal was this incredibly strong, very, quote, narrow band signal. And by narrow band, I mean like the way a radio station is narrow, and if you turn it down, it's gonna go to another station, you turn it up, go to another station. It's a very narrow signal. It was very, very, very strong, very loud. And it was exactly in the place that you would expect a radio signal to be if somebody was trying to communicate with you from another star system. It was in what we call creatively the water hole. And so that has been a mystery for since the 60s or the 70s. And recently we figured out what it was. So there are hydrogen gas clouds in that patch of the sky where we first encountered the wow signal. And those hydrogen clouds are in front of something that blew up real crazy style. And it lit that cloud up like a Christmas tree. And that's what we saw. We saw all these, we saw basically a gamma ray burst or a supernova or a neutron star merger or something real crazy, lighting up a gas cloud in front of it, and we just happened to be scanning the sky at that moment. Because we actually see little tiny versions of those events all the time in that patch of the sky. So this was just a real crazy one.
Yeah, the wow signal is one of those things where it has such rich history, and I think in pop culture too, it's been referenced so many times. I should ask you about pop culture. I think a lot of things that you cover in the book are things that sort of get shout outs in various media, like you mentioned Star Trek already. Can you maybe talk a little bit about how the Drake equation is a pop culture object too, and not just a science object?
Yeah, it really is kind of a vehicle for us to, dream about how many worlds could be out there and just how populated the galaxy is. Because like my favorite media, Star Trek, the thing I have 5 tattoos about, and I kind of have a name about as well. In Star Trek, there's life on basically every system, and there's always something amazing and cool to be learned about the universe. And so it was just so special for me when I discovered that connection that Gene Roddenberry, 3 years after Frank Drake wrote that equation on a chalkboard, Gene Roddenberry heard about it and he was like, maybe there is a lot of life in the universe, and I can use this to justify why I should be given an amazing television show about it. That's the most special connection to me.
Yeah, I mean this is amazing. I think ties so nicely into what you were saying before about starship imagination. This equation is an invitation for people to dream and imagine, and sometimes you get something incredible like Star Trek out of it. Sometimes you get bad things out of it too.
Like Star Trek Enterprise.
I will say absolutely nothing about Star Trek Enterprise. But I think sometimes people have more nefarious imagination. We hear a lot of talk about space colonization, about colonizing Mars, about building nuclear reactors on the moon, from the perspective of someone who's really studied the idea of life in outer space through the Drake equation. What is sort of your take on the idea of becoming a spacefaring nation?
So I like to refer to the private space industry as the billionaire reputation laundromat. Because that's who's going to space. And I actually had a really interesting discussion with one of my students about it just today, where she's like, well, when NASA goes to the moon or something, they invent all this technology along the way. Well, so isn't SpaceX doing that? And I was like, there's this word called proprietary that gets, used and abused in the private space industry. So I really have a lot of thoughts about how it's this beautiful but empty show of like what you can do if you have been given way too much money. And especially this idea of going to Mars specifically is something that I have even more complicated feelings about because I personally hate Elon Musk. My personal beef with Elon is that he ruined Twitter, and that was my home, and that was my community, and he just burned it to the ground, and nobody's there anymore. My other beef with him, besides his, billionaire, now he's a trillionaire. Eat the rich, eat the rich. That's in here twice. That's the politest term I can possibly put into this book. Otherwise, the legal team has to talk to me. I only got in trouble with the legal team once. That's pretty good. Anyway, so you can't terraform Mars. There's no magnetic field. The magnetic field for Mars shut off a long time ago because Mars is actually significantly smaller than the Earth. Sorry, Mars. Mars is smaller than the Earth. And it actually cooled more quickly, and so the thing that makes the Earth this like boiling magnetic dynamo is shut down on Mars. You can't get it started again. No matter what you do to put an atmosphere on Mars, it's just gonna go away pretty quick, but there's nothing protecting it. Also, as I learned recently, there is there's one law in the United States. You're not allowed to lie to investors. So, Elon is allowed to, he can't get up on a stage and say, I'm going to build a city on Mars, so give me $1 gazillion, pump up the SpaceX stocks, we're all going to Mars. But he can file a thing with the SEC that says, if I build a city on Mars, I'm going to get a lot of money. Wink, wink. Because again, the only thing you're not allowed to do in the U.S. is lie to investors. So that's kind of one of the more recent developments in that sphere is that, there's blah, blah, blah tax fraud. Anyway, so Mars has no magnetic field, you can't terraform it, and there's definitely not going to be a city of 1 million people and a brand new frontier of labor law violations there. It's just not going to happen.
Yeah, I mean, this is a great answer because I think it illustrates how many things come together when we start talking about space in this way. Like, you have to talk about the SEC, but also the magnetic field on Mars, and we have to have hard science, but also understanding of civilization, which I think again recommends this idea that the Drake equation is really an excuse to talk about everything put together all at once. I believe there's a section in the book about leaving the planet. Maybe you can read a little more for us before we go into some audience questions.
Yeah. Let me, okay, fortunately I bookmarked it.
We'll do reading questions and then we'll do a part 2. So think of a question now, and if you're shy, you can save it for the end.
Yeah, if you're shy, I'm gonna walk up to you and stare in your face until you come up with a question, especially if you're in the front row. Okay, this section is called Becoming Interstellar.
What page?
It's on page 167. Class, please turn to page 167. Escaping our planet, at least in the next century or so, is not going to happen. There is, as they say, no planet B. Not in our solar system anyways. With Venus too hot to step on and too acidic to float on, and Mars, stubbornly refusing to hold on to an atmosphere, it's only natural that humans should shift their gaze farther out. So far, we've discovered thousands of other planets in the nearby Milky Way. Only a handful of those are the size of the Earth, and of those, fewer orbit in the habitable zone, and fewer yet may actually be habitable. Nonetheless, one day humanity may discover our cosmic twin, but how will we get there? It's impossible for the human mind to comprehend just how vast space is, but let's try anyways. Driving at 60 miles an hour, it actually takes just over an hour to reach outer space. But let's take a field trip to the moon. That's 166 days. Mars, If Mars was as close as possible to the Earth, that would be 64.5 years. What about Neptune's closest approach? 5,136 years. You get the idea. Of course, we don't drive cars to space, we use rockets. And rockets must be going a minimum of 17,500 miles per hour just to get into orbit. And the fastest speed by a spacecraft these days is actually 430,000 miles an hour, which occurred when the Parker Solar Probe made a close pass to the Sun in 2025. At this speed, one could reach Neptune in just 262 days. That's a lot better, but we're still in our own neighborhood. To reach our nearest star, Alpha Centauri, with the Parker Solar Probe, one would have to travel for 6,600 years. Now we begin to see the scale of the problem. The universe, as we know, has a speed limit, and the speed limit may be the great upper bound of multi-star civilizations. Nothing can move faster than light speed, 670 million miles per hour. For reference, the Parker Solar Probe is moving at 0.06% the speed of light. This may seem pretty fast, but it's still no match for the overwhelming distance between stars. Even at the speed of light, it would take 4.37 years to reach Alpha Centauri. The speed of light actually helped us to define a very useful unit of measurement, a light year, or the distance that a beam of light travels in one Earth year. Instead of saying this star is several hundred million miles away, we can say the star is a dozen light years away. A similar unit of measurement is the parsec, which is not a unit of time, thanks Star Wars, but distance. A parsec is 3.26 light years, and it is what astronomers use to tell each other how far things are apart in space. The center of the galaxy is about 8,000 parsecs away. All this is to say that things in space are unimaginably far apart, and today's spacefaring technology is untenably slow. Barring the invention of alien-style suspended animation, where you would sleep through a centuries-long journey to another world, or generation ships, in which you don't reach your destination but your descendants do, it seems like we're stuck here for now. But humans are nothing if not dreamers, and it turns out that there are a number of ways we have invented to skirt the universe's strict speed limit. There's actually two ways to do this that do not technically violate the laws of physics. Both of them involve manipulating the fabric of space-time rather than the spaceship. Like an irritating child seeking a bedtime loophole, physicists have needled Einstein's equations until they threw their hands up and said, fine, I guess you can achieve faster than light, but your father had better not hear about this. You'll have to read more to figure out how we actually violate the speed of light.
Can we have some more applause for 7? Yeah. Okay, I think we can do like 2 questions, and then we'll do a little bit more chit chat, and then we'll go to questions again. So if you have a question, please raise your hand real high. I used to be a high school teacher, so I will see your hand. Yes, go for it.
Can the human body actually travel that fast without it like tearing us apart?
Is the human body what?
Can it travel that fast?
Can the human body travel that fast? That's a really good point, because you can travel like really quickly, but you can't decelerate or accelerate really quickly. Because acceleration's like what you feel when you're in a car and you step on the gas and you zoom off, or like when you like hit the brakes and you jerk forward. Acceleration is something that your body can't deal with very well. Even trained fighter jet pilots can't handle more than 10 times Earth gravity, or like 10 G's if you heard it that way. So we can become real speedy, but we have to go pretty slow on the way to becoming really speedy. But yet another barrier to interstellar travel.
Great
Good question.
Here.
It feels like the Drake equation is kind of a close cousin or mirror image of the Fermi paradox. What would you say are your favorite answers to the Fermi paradox, and what you feel at the moment is the most likely answer?
Can you give us a 101 on what the Fermi paradox is?
Yeah, so the Fermi paradox is the question of where's everybody else? Why haven't we heard from our interstellar neighbors? If we've evolved here on the Earth to become so, we've invented the hot dog roller, for sure, upon which you might commit the crime of cream cheese. Basically, like, where is everybody else? In the galaxy, why is it so quiet? Why does it seem like it's just us? And so I think one of my favorite, like, it feels kind of hostile and almost like an RPG, the dark forest hypothesis, speculates that maybe everybody's scared of everybody else. Like, you know, you're in a dark forest and you light a campfire, so maybe other people will see your campfire, but maybe a bear will see your campfire and eat you. So that is kind of that's one of my favorite, like, kind of spooky answers to the Fermi paradox. What's more likely is that we've only had the hot dog roller for about 100 years, order of magnitude estimate. And so if the hot dog roller also somehow powers interstellar communication, the universe is real old. It's like 13.8 billion years old. Notably, that's several orders of magnitude longer than we have had the capability to talk to other people. And then you also got to think about the last term of the Drake equation, the L, the average lifetime of a technological and communicating civilization. So if that value is not very high, the chances that we're going to, you know, be ships in the night with other civilizations is pretty high, whether they're out there or not. Personally, I think that civilization that exists at this highly technological level it flickers to me. We're at this level where we could communicate with another star system, but then maybe they're dark ages, and maybe we come back and there's a renaissance, and then there's the medieval dark ages again. So to me, my idea of civilization is that it's kind of like, not to be like real poetic, but like maybe flickering candles in the Milky Way.
Beautiful. I think I saw one more hand, so let's do one more. Yes, go for it.
Yeah, so it's more of like it's like kind of like material science kind of question. And it's like, as a, you know, growing up with like Star Wars and Star Trek and all that stuff, and like all of these shows that Star Wars, Star Trek, you know, Mass Effect and so on and so forth. And they're so like all these spaceships that can like travel the speed of like a warp drive and stuff. It's like, what legit, like what kind of like material, like technology / like material science would even like go into developing, not even like the warp drive stuff, like holes, like hole design, the stuff that can actually like bend space and like actually like facilitate faster like travel. If that's a long question, I apologize.
Yeah. So what does it take to build the warp drive?
Right.
Is the question. Yeah.
Yeah.
So there is really such a theoretical thing as the warp drive. It's called the Alcubierre drive, invented by a Mexican astrophysicist in the last like 2 decades or so. And so the Alcubierre drive is this idea that if you can warp space-time around the ship and then take that warp bubble, it really is not constrained by the speed of light, because only things in the universe have to follow the laws of the universe. The universe itself go as fast as it wants. That's how the universe is way bigger than what we can see of it, because it has expanded faster than the speed of light. So space-time itself can go as fast as it wants, and if we could somehow like wrap ourselves in a bubble of space-time, we could also go as fast as we wanted, which is the kind of the concept of both the Star Trek warp drive and the Alcubierre drive. So materially, what you would need to do is create kind of like a, if you imagine putting like a stretchy sheet of rubber or fabric or something, and you put a ping pong ball on it, and then you take like a Solo cup. It's kind of a beer pong analogy we're going for here. And you take like the Solo cup and you like scoop it under the ping pong ball and you like zip it along the fabric. That's kind of what's happening with the fabric of space-time, is that you're creating something, a space-time push from behind and a space-time pull in the front. And what you would actually need to physically do that is this mass is really good at creating gravity, which would pull the spaceship, and we'd also need to have anti-gravity, which would require anti-mass. And for a long time, people thought that antimatter maybe had anti-mass, but it turned out that particle physicists can comment, antimatter has regular mass. It does not create it's not negative mass. So we are lacking the technology to create anti-gravity that would maybe propel something like a warp drive.
Yeah, I think-
Carmela, can you comment a little bit on that?
I can comment. I think it's worth saying that, like, we know that masses warp space-time. That part's not difficult because the Earth does it. We can see how light doesn't travel in straight lines near planets. That's because of gravity. So we know that this idea of the rubbery sheet sort of being distorted by things that you put on it, like, we are very solid on that. But the question is, how can you do that in a non-attractive way? Like, gravity is always attractive. You sort of get these like bowl shapes underneath planets and whatnot, and we need to go the other way. Antimatter, as Evan was just saying, like, we have now become really good at manipulating it. Like, at CERN, there is a genuine truck that delivers anti-hydrogen atoms to labs around the area if they want to study them. And antimatter, you know, it's anti in the sense of it has opposite quantum numbers of regular matter, but it falls downwards under the influence of gravity, and it has positive mass. And if it has positive mass, it will sit on that rubbery sheet just like anything made of regular matter. So we need some sort of like negative energy, anti-energy type thing, which general relativity doesn't necessarily completely forbid, but technologically, how would you make that happen is a complete mystery. People sometimes evoke black holes, but what happens inside the black hole is really that our theories break down. It's unclear whether it's a physical effect that lets you do something extreme to space-time. So I think the real question is, and I think what you were sort of asking is like, what would a ship have to be made out of to survive a warp drive? The real question is like, how do you even create the bubble that Seven was describing? And we've just not made it there yet. You can read about wormholes, which are sort of like in a similar neighborhood of ideas, and like how to keep a wormhole open just long enough to send a message, let alone a physical object, is also another huge open question that basically you can simulate in the lab with quantum particles. Once you try to go space size, it all falls apart. So the quest for the warp bubble, it continues.
I have a really burning. What classification of license do you need to drive the antimatter truck? Can you get forklift certified to drive, like antimatter certified?
I don't know actually, but I hope it's the same thing that you need to drive like atomic clocks across the border.
Okay.
You know, there's a whole universe of weird physics things you can put in a truck and drive them around Germany or Switzerland. So we should look into this.
I think we should. I really do want to know like what it takes to drive the antimatter truck.
I think we should go on like a
field trip.
Exactly.
Field trip.
Exactly.
Okay.
Okay, great. This was a great question. Thank you for giving us a chance to talk some hardcore physics. I wanted to ask you another sort of hardcore physics-ish question, and then we're going to move into the more whimsical portion of the night.
Excellent. I love whimsy.
In the recent years, we've seen a remarkable amount of instruments come online that can help us see the cosmos in new ways, from sort of LIGO, which is letting us see the gravitational wave universe, to various infrared surveys, to JWST, to DESI. Like, there's so many instruments now, and they're still coming online. If the Trump administration doesn't cut all the funding for everything, but there's so much coming.
They will get better.
So what's on your wish list? Where should people be looking? Where should we point all of these instruments we have? Like, what are the corners of the universe that you think, having studied the Drake equation, people should be looking at?
My thing about exoplanets is that we haven't really found the really good ones yet.
Say what an exoplanet is.
An exoplanet is a planet that orbits another star, and we haven't really gotten to like the really good juicy ones yet. It turns out that compared to their stars, they're pretty small. And an analogy that I came up with for the book is that if you're trying, imagine you have a stadium light, and you're trying to measure a moth flying across the stadium light. Maybe the moth blocks 1/1,000,000th of the light. But maybe one of the light bulbs is flickering, and that flicker goes up and down like 1/1000th of the light. That's what's happening when we're trying to study Earth-sized planets around sun-like stars. Is that we just don't have the technology to follow the moth yet. So my wish list is something that we can follow the moth with. I think the closest thing that's coming up is called the Habitable Worlds Observatory. which is a basically exclusive exoplanet hunting device, which will have cameras so advanced that they haven't been developed by NASA, probably only by the defense industry, which does not share its secrets. But NASA needs to really develop some really cool technology for this telescope, like really advanced things where you can block out the starlight and take like a direct picture of the planet and stuff like that. So the Habitable Worlds Observatory, which is allegedly going to launch in the 2040s, will bring us the kind of like moth crossing a stadium-like kind of sensitivity that we need to find the kind of solar system that we would call Earth analogs.
Okay, great. Which exoplanets are the most clear?
Which exoplanets?
Or if you want to throw in a
Space
regular,
objects.
if you want to throw in
Okay.
a regular planet or a neutron star or something in there
Okay.
too, you're allowed. But give us like top 3 planet adjacent to planet-like things in the universe that are most clear in your personal estimation.
Okay, so first things first, everything is queer. Everything in space, I asked it personally and it said yes, I'm queer. That's what astronomy is all about. Let's see, things in the solar system that are, okay, so we all know that the moon's a lesbian. That kind of queer space 101, we all know that.
What's the lesbian? The moon.
The moon is a lesbian.
Oh, okay.
Yeah, so I'm also going to say that the sun is screaming at a volume that if we could hear it on the Earth, it would be about about the volume of like a rock concert, like 100 decibels or so, and the sun's pretty far away. So the sun is screaming all the time, and it's also, you can't look directly at it, and that's kind of a gender to me. Screaming and eldritch can't be perceived, that's a gender. And finally, I want to say that every star that does not have a companion is in fact a non-binary star.
That was masterful. We're doing such incredible work here.
This is what my real PhD was in shit posting on Twitter.
Yes. I too. Seven and me know each other from Twitter when it was good, so I too miss Twitter pre-Elon. Let's do another whimsical question, which is if you could time travel and meet Frank Drake before he wrote the equation on that blackboard on that day that you described for us, like what would you say to him? Do you have advice for Frank Drake?
I would tell him that he's perfect. I honestly, he was really cooking when he came up with the Drake equation. He did it in like 3 days before a conference because he was like, oh God, I've got a conference, I gotta present something, as so many of us do. And then he was just absolutely cooking with the equation. The other thing I would ask him is if he could give my number to Carl Sagan.
Yeah. Do you think there's like things that he didn't foresee? Did he expect at all that the Drake equation will become the behemoth it is today?
You know, I guess what's a little bit sad is that he was alive when I started this book. And I had a big email draft full of questions for him, and then he passed away in 2022. I didn't get to ask him any of the questions, although I did talk to his daughter Nadia, who is a science journalist, and she gave me her blessing for this book, which was very cool of her.
Oh, that's amazing. Can we have a round of applause for
Nadia.
Nadia?
She does a lot of cool stuff for National Geographic, I think.
Okay, very cool. Okay, we have to talk about like the aliens of it all. Just earlier this year, the government released this like trove of files about UFOs, some of which were clearly nonsense. What is the political and cultural value of governments dabbling in UFOs?
The Trump administration is setting fires so that you will put the fires out instead of protesting fascism, and the UFOs are just one such fire. That's what I got to say about that.
No, that was amazing. That was amazing. Invest in mutual aid, not UFOs. But maybe on a lighter note, do you have favorite UFO conspiracy theories, or do people write to you with crazy ideas about aliens? Give us a flavor.
I actually have a really good story about this. So I was in Fort Myers, Florida, and I bought an old book at a bookstore that belonged to a cult.
Ooh.
And it was called the Khorasan cult. And notably, I was kind of like refreshing my memory on this cult, and it turns out that they believe God is by gender, which fucks absolutely. But they did have some less good ideas about the Earth. They did believe that the Earth was round, but they thought that we were on the inside of it. Yeah, and so they actually kind of they devised an incredibly silly experiment to test whether the Earth was, in fact, that we live on the inside of it. They were like, we're going to take a really long stick and put it out over the ocean, and when the stick dips into the ocean, then we will know the ocean is curved. Not taking into account that we don't actually have any of the perfectly rigid materials that we love to talk about in physics problems. That's probably my favorite bit.
So was the bigender God an alien?
I think it was just the regular degular Bible lady. They referred to the God as she. But God was definitely both a man and a woman. She appeared to the cult leader and said, "You have to make a lot of money."
as gods do.
Yeah.
What's a pop culture depiction of aliens that's so bad it's actually good?
Okay, so hot take, but like there's no such thing as anti-gravity, as we discussed. And so every time I see like a spaceship that's shaped like a ship, like a water ship, like a regular store brand water ship, even remotely, like the Starship Enterprise, you could put that thing in water. I think they do it like 3 times. Anyways, there's no floor. You can't just put the anti-gravity panels under the floor, and then there's gravity, but then I don't know, there's a bunch of floors, and all the floors have anti-gravity, and Star Trek does this, and a lot of science fiction does this, but the one thing that I hate is the anti-gravity floor.
So floor in space bad.
Floor in space bad.
Okay. Abolish floors in space.
Abolish floors in space.
Maybe you can tell us about sort of the best idea of aliens that you've heard of in your research. Like, what's a sort of realistic or is it gonna be like some tiny guy bacterium in some tiny rock somewhere very dusty? Like, should we forget about floors and spaceships, focus on the tiny guy bacterium?
Well, I mean, I really like the Star Trek idea that there's aliens and all of them have weird foreheads for budget reasons. Okay, but realistically, life got started on Earth about 4 billion years ago, give or take a couple 100 million years. However, it was only 500 million years ago that we got those weird flappy little wiggly boys of the Precambrian and the regular Cambrian. And then it's so likely that life has to spend a long time like cooking as a little germy boy before it gets big and wiggly. I follow me for more interesting opinions about evolution. This is actually the topic of my second book. My wonderful agent, who could not be here tonight, is going to help me sell a book about the evolution of life, which will be even shitpostier. And I'm definitely going to refer to various biota as wiggly little guys a lot, because there's a lot of words for things that are alive, and I don't know any of them.
So final question before we go back to the audience. If we talked again in, say, 10 years, we're going to be older, hotter, and smarter. Are there going to be wiggly guys on an exoplanet that we saw with the new telescope?
I think that there will be like very tiny wiggly boys.
But you think we will find something?
I mean, I really think that there's life everywhere in the universe. But again, it's just tiny little guys just germing around, hanging out, They're unbothered, they don't pay taxes, they don't have to go to wellness seminars. They're living their best flappy little lives. They're flagellar, they're just going nuts in there. They're having a really good time. They don't have capitalism at all.
I want that. It's like me and my boys drumming around on Mars. Well, no,
Yeah, me and the boys. I don't even remember what the question was, but I want you to take away that the galaxy is full of wiggly little guys. I think we're going to find wiggly little guys on Titan. I think we will find evidence of past wiggly little guys on Mars. I really hope that detection of ocean scent that they found on that hydrogen world will turn out to be real. Let me tell you about that. Okay, so if you go out into the ocean, it smells kind of funky out there, ocean smell. That smell is a molecule called DMS. And so there was kind of like a very trace detection of maybe DMS on a somewhat nearby exoplanet. And so I'd really like them to get some more data and build that up because, maybe there's, I don't know, like plankton or, I think it is plankton that they make the ocean smell.
There is a whole category of exoplanet that's just straight up cold water world.
Yeah.
And it would be super cool if we learn more about the water worlds out there. So holding my fingers crossed for that.
I also hope they have like really big whales there too.
Like in Voyage Home.
Yeah. The documentary, The Voyage Home.
If you have not seen Star Trek Voyage Home, you absolutely, this is your homework. You have to go home and watch Star Trek Voyage Home. Okay, I think we can do a couple more questions. We're doing super good on time before we go to signing. I see a hand, go for it.
Sorry.
Hi, Joe.
Hi. So I happen to know that Seven, on top of being a science writer, is also an extremely talented fictional writer. I've heard anecdotes from like other friends about that work both in science and in creative fields. But maybe you have one as well about how in your science practice, your sort of imagination or intuition in like a fictional sense has kind of like interacted with your scientific practice.
Okay, this is a really good question. Okay, so basically, like, how does my physics knowledge interact with my science fiction writing? When I started writing science fiction in 2018, I was like, oh, I'm gonna be so good at this because I know all the physics. And I was floored to find out that that's not the case. It turns out you have to tell a good story, you gotta know about like people and stuff. And like what people are up to generally. And as a nerd in graduate school, that was really hard because I was surrounded by other nerds. I was living like a physics version of like Arrested Development.
Who among us has not been there?
Yeah, who amongst us? So I was insanely humbled to find out that knowing about general relativity doesn't actually help you write a good science fiction story. But fortunately, I started talking to people, and then I was like, oh, people have got some real fucked up shit going on. I'm gonna write about that.
Since we're talking about writing, one thing about your writing is like it's very colorful and hilarious. Can you talk a little bit about whether science writing needs more humor?
Yes, absolutely. If you're entertaining enough, people will listen to you say like whatever. Like you can. We're talking about hot dogs here. We're having an intelligent discussion about the awful things that you could put on a hot dog because it's really funny. Even though if I had a diagram of a cow up here, you'd be like, ugh, get out of here. So people will listen to you like no matter what, as long as you're really entertaining about it. And so science is one of those things where we need to tell people about it. People have to be aware of the horrors and the climate changes, and really mostly the climate changes. So if you can entertain somebody, you can educate. You can tell them whatever. You can educate them in like literally anything, as long as you have a funny story about it. So I mean, if people really just wanted to learn about equations, they'd pick up a textbook. but they don't. They want to read something silly, so hopefully they'll pick up this book.
Great. Let's do more audience questions. Yes.
So we don't like floors in our spaceships. Setting Star Trek aside, sorry. What is your favorite spaceship in science fiction?
My favorite. Well, okay. So this is like asking me to choose a favorite child. I mean, can I pick the Deep Space Nine station? I know it's not a spaceship, but it's kind of out there.
But I was setting Star Trek aside.
Oh, shit. Okay, I know that The Expanse does a really good job with like hard sci-fi. Like shout out to all the weird physics that they're constantly doing on the I want to call it the roundabout, but that's Deep Space Nine. You know, the thing they're doing stuff on. Sometimes they're floating. They got the budget to do that. Sometimes things are spinning. The Expanse does a really good job with realistic ships, I think.
Well, let's do Mars.
So,
Hi, Mars.
hi. So.
You've been discussed a lot tonight.
I know it's not me, just my namesake. But, okay, so this may not be a coherent question, but let me see if I can find it. Like you were reading in that section earlier when you just talked about the sheer, like, scale of everything. Like, everything.
Space big.
What?
Space big.
Yeah.
Astrophysicist here, space big.
like, okay, the world that we can already, like, see and touch and observe here is, like, already, like, so complicated. And
Earth
yet
big.
you're, like, studying things that you have no way of, like, ever approaching. And, like, based on what I've read so far, maybe, like, 100 pages in, and, like, it's just nuts to me how much you can theorize and speculate and explain from stuff with like very, very little information, just because of like how really super duper far away everything is. So it just like kind of like blows my mind, you know, like that like.
That blows my mind too. Yeah.
Yeah, like you can like measure presence of a specific element of something, and just like based on the amount of hydrogen in this thing hundreds of light years away, we can this and this, and I'm just like how, like that's.
No, you're incredibly correct to say that, because it's super fucked up how much we know about the universe, even though it's just light. Like that's how we know almost everything about the universe is starlight. And shout out to spectroscopy, because that's like the gayest part of astronomy. You literally have to take the starlight and you have to split it up into the rainbow in order to understand the composition of the thing that's producing the light. You have to make rainbows. It's pretty good. It's pretty gay. Yeah, it is extremely remarkable that we know anything about things that are like millions of light years away. All I can say is, yeah, it's crazy. Yeah, I mean, that's one of the things that really drew me to astrophysics, is that it is so boundlessly big. Like, we'll never know everything about space, and it just so it's like in kind of a spiritual way. It's like so unfathomably immeasurable that it's kind of comforting to me. That it's just, there's so much out there, and I'll probably never know all of it. Kind of like I live in New York, and I'm never going to see every block of New York. But that's why I love New York, because it's big and full of possibilities, and that's also why I love outer space, because it's big and full of possibilities.
Yeah, I think it's worth saying also that like this is why science has to be a team sport. Like spectroscopy doesn't work if you don't understand atoms, and you don't understand atoms if you don't know quantum mechanics. And the folks who invented quantum mechanics weren't thinking about stars for the most part, but then astrophysicists came and like scooped up their knowledge and turned it into something that now lets us, people sometimes say this, that like the universe speaks in the language of light and we're just learning how to read it. We couldn't do that if we didn't have all of these little bits and pieces of science that people have done over centuries together. Like the vastness of the space is remarkable, but we can come to approach it because we can work together. So I think there's a really nice, or like astrobiology is 20 sciences in a lab coat, like all of science is actually
That's actually
kinda
much
like
better
that.
than the trench coat analogy. I'm
Like-
taking that.
I'll go for it. I am a professional writer, but I think we can know things because we have gathered all these bits and pieces and we are putting them together and we're working together, and that synergy I think is like as important as the scales. Like we may not never know everything, but sort of like not separating the sciences. Like in astrobiology that really thrives on this.
They call that the warmth of collectivism.
We love collectivism
Oh,
in New York
yeah.
City.
It's protecting against the cold winter of individualism.
Let's do more questions. We're doing great on time. Yes, go for it.
Okay, so tomorrow, aliens land on Earth. What do? What's your reaction? Do you try to kiss them immediately or like take them on a date first?
Yeah, I mean, I'm pretty much going for it.
Obviously.
Yeah. Let's see, aliens land on the planet tomorrow. I mean, are they hanging out? Are they gonna kiss Zephram Cochrane on the lips? There's a lot of fan fiction about that. Let me
You're
tell
the
you, I've read
expert.
all of it. Yeah, I mean, are the aliens sexy, or do they have ray guns that they're going to kill us with?
I mean, that could also be sexy.
Are we going to look at some inky time wiggles and have future memories about our trauma?
Also sexy.
Yeah, that could be
potentially.
sexy too. Everything. This is astrophysics, and everything is possible.
I'd fuck a time
Everything
wiggle.
is beautiful, and everything is sexy in astrophysics.
Yeah.
So I'm gonna smooch them on the lips immediately.
Hell yeah. What if they don't have lips?
And then I'm gonna there's a lot of there's this textbook called Archive of Our Own, and you can do some research into that textbook, and there's a lot of hypotheses out there.
Great scholarly work.
Yeah, it's often peer reviewed very well.
Yes, Joe.
Just
Spooky Joe.
hi. How have your studies of the limitlessness of the universe and the limitations we have in studying and understanding it changed your view of yourself as a human? Or where do you
Good
find
question.
your sense of humanity in this exploration?
Yeah, what is my sense of humanity in the cosmos? I would call myself
not
like
just humanity, because most, like right now, everyone's an idiot, but like you and your humanity.
I would call myself like a cheerful nihilist. It's just so big, and every means of information that we have, every means of recording information we have is imperfect. So there's going to be a point in the universe where that the Earth has been atomized, and maybe it's actually been swept up into a brand new solar system. I mean, our atoms were born, a lot of them, in the Big Bang, and they'll be here for trillions of years to come, which I find very reassuring. I think sometimes people ask me at events like these, they ask me like, what is the meaning of life? And I'm like, uh-oh. But then, I actually kind of, I've come to develop an answer for that question. And the answer to that question is the same as, like, what's the point of a tree? A tree doesn't have a point, it's just there, it's hanging out, being leafy. That's also like, why am I here? Just hanging out. I'm a little guy, I'm hanging out. I'm enjoying the ride. That's kind of I would say that is how being an astrophysicist has influenced my personal philosophy. Good question.
I think we can do maybe two more. In the back.
Hello.
As two Star Trek professionals, what's the Star Trek technology that you want the most and that you think is most likely to exist in your lifetime?
Okay, I can take that second one. Is that there is an incredibly funny thing they do in Star Trek: The Next Generation where they have correctly predicted that we will have tablets, but they don't know that you can put multiple books on a tablet. So you will see like
Yeah, that's
Riker or
good.
Picard like pack several tablets when they go on a trip, the way you would pack several books, because they couldn't imagine putting 2 books on one tablet. So I do love that. This is such a boring answer, but like I would like to be teleported, even if it creates like a copy of myself that's not quite myself. Like I would still love to avoid air travel. Like air travel's gotten so bad, and I have family abroad, so if I could teleport, like I would take the little death that's in between, like being here and being at my mom's house. I would take.
What
it.
if you get teleporter cloned? What are you gonna do?
I think my clone would be really cool.
Would you kiss them?
Like maybe my clone would like be better than me, and my mom could hang out with my clone and be
Well,
happy.
that's an incredibly thoughtful but kind of dark answer. My answer is just a long redacted block.
Yeah, same.
Do you have a technology from Star Trek that you want to shout out?
Boy, I don't know. I also really love the idea that I could just be atomized and then reappear somewhere else. I'm trying to think of. I don't know. I also just want to, I want to zip around the universe. I want to see what kind of foreheads are out there.
I think the rational answer is tricoders, where you can get like a full physical without having to like charge your health insurance. You just need like a guy with a tricoder, and he will do it.
Yeah.
And I think we could probably have that in the future. It's just going to be proprietary and cost a lot of money.
Well, they tried to do that with their announced kind
Hey, that's what I was gonna say.
Right, and that was a scam. So, yeah. I think one more maybe. Yeah, go for it.
Hi, V.
Hey. Aside from Star Trek, what I guess like forms of media would you say have the most accurate representations of physics or astronomy?
Dang, I guess I already kind of shouted out The Expanse. I mean, they really, they went like all the way hard science with it, minus the blue goopy stuff, the crashes in the Venus. I don't know, I didn't finish the series. God, what other, I think that Becky Chambers does a really good job in her novels of kind of splitting the difference between like, this is scientifically accurate versus this is not scientifically accurate, but it kind of tucked in there, so nobody's gonna really ask too many questions. I read her novella, To Be Taught If Fortunate, and then I like cried the whole way from Seattle to Detroit on the airplane. It was really good and really meaningful to me, and the science was so well done that even though lots of impossible things were happening, I didn't question it. So I would recommend Becky Chambers, I think.
It's a really long cry.
Yeah. Well, it's 4 hours from Seattle to Detroit, and you can absolutely cry for 4 hours. Let me tell you that.
There's no law of physics that will forbid you from crying.
That's
for 4
right.
hours.
That's right.
Okay, great. I think we're going to wrap here. Thank you all for your patience. You can now come up and get your book signed by 7.
Yay.
You can shower her with compliments.
Yay! I'm
thank you
gonna
so
draw
much
a
for
weird,
listening.
wibbly, blobbly little guy in your book. They'll all be different. Thank you. Thank you for coming. I love you.